And thanks for the introduction. So in this presentation, together with my co-authors, within this project, we have carried out some study on the fracture behavior and mechanical characterization of R350HT. R350HT is a rail steel, is a higher grade rail steel, and in general, within the rail industry, it is needed to increase the rail steel grade in order to reduce proneness to plastic deformation, wear, and the crack initiation, of the crack initiation. R350HT is composition-wise very similar to the most common R260 rail steel, and but is obtained essentially by heat treatment, by basically faster cooling rates, thus reducing the lamellar spacing in the perlite. This strengthening, so basically could potentially reduce damage tolerance, which is also a very sensitive topic in railway. Therefore, we carried out a test program on a few samples of R350HT, which is presented in this slide. And starting with the monotonic tensile test, we have extracted this tensile test according to the indications of the rail standard, of the European standard EN 13674. So the specimens were extracted from the railhead, and prior to testing, some very light heat treatment was performed by maintaining the sample at 200 Celsius for 6 hours, potentially to reduce a bit of superficial residual stress and increase ductility. The tests were performed into a universal testing machine with a load capacity of 250 kilonewton by constant crosshead speed of 0.75 millimeter per minute, and the elongation was measured through an optical extensometer. Okay. Yeah. You should go to the next slide. The monotonic as a result of the monotonic tensile test, we obtained the curves that are represented here, very let's say uniform between left and right side of the railhead, and on the fracture surface and on the remaining part of the monotonic tensile test, we have performed some investigation at the microscope. Generally, as also it's identifiable microscopically, there is a brittle fracture morphology with some, as you can see in the red frame, with some ductile area which is associated to the intergranular ferrite. As you can see, there are some dimples indicating indeed the ductile behavior. In green, you see the appearance of a radial longitudinal section, and also in this case we found some multiple cracks in this section, which were associated to the fracture of the ferrite, and close to the surface. So this is the fracture surface in the bottom. You can see the necking profile and the ductile, shear failure immediately in the vicinity of the surface, so the stress is more for plane stress, and in the immediate vicinity intergranular type of fracture. The fracture toughness tests were carried out on CT specimens, which were extracted from the railhead. Since we had the UEC 54 rails, we could not extract 25 millimeter wide specimens. Therefore, we used W40 and B20 as the dimensions of the specimens, with the notch pointing downwards. The specimens were machined producing integral knife edges. Therefore, the crack compliance was measured using CT, the clip-on displacement gauge. And as a result of this test, you can see here one of the curves. Essentially, what we realized is that at room temperature, a valid K1C test was very difficult to obtain according to the American standard, although mostly because of the prerequisite of having a ratio between maximum load and PQ, let's say lower than 1.10%, but this condition was waived somehow into the European standard. Therefore, we had a valid test according to the European standard, and according to the American standard, a valid K1SI test, a size-insensitive fracture toughness, plane strain fracture toughness. In this case, the slope of the secant that is used to calculate and identify PQ is not the 95%, but is a function of the remaining ligament, is a relatively new procedure in the standard, and therefore is related to a fixed crack extension of 0.5 millimeter instead of the 2%, which is underlying the estimation of K1C. Related to the surface, you can see in the green box, this is the crack front of the. Oh, you don't see that. This is the crack front of the pre-crack, and you can see the onset of cleavage cracking and several initiation points. Even at room temperature, there was no really ductile tearing because it's a very brittle steel. And more into the far away from the crack front of the pre-crack, you can always see, as in the tensile test, some zones which are associated with the intergranular ferrite in the yellow box, where some ductile fractures occur. Relating to the fatigue crack grow rate, I think presentation is, yeah. Related to the fatigue crack grow rate tests, we have performed tests in using two load ratios, but only one is reported in this presentation for sake of time. You can see here the experimental data compared with the Paris curve from literature, and this Paris curve were actually obtained for R260. Just to make a comparison, we can say that generally the fatigue crack rate is not much higher than what you obtain in R260 rail steel. As analysis of the fracture surface, you can observe here the macroscopic appearance of the fracture surface, with this being the from left to right, the crack growth direction under constant in the delta P. That's how we perform the test. The constant load range. On the going from left to right, we observed an increased roughness, so different higher depth of the fracture surface, and the crack growth was characterized as intergranular crack growth. So therefore, a smoother surface is obtained at the lower crack propagation rates. Going to the conclusions, monotonic tensile test properties generally are uniform within the head and generally higher than R260. Rail steel, usually the number for these rail steels identifies the Brinell hardness. The morphology of the fracture surface reveals a typical brittle fracture type with some limited necking. Multiple cracking sites were associated to intergranular ferrite. A valid K1SI according to the STM E399 standard was obtained, and the valid K1C test result according to the European standard were obtained for the W 40 millimeter CT specimen at room temperature. A ductile behavior is locally exhibited due to the intergranular ferrite. A fatigue crack rate is similar as R260 rail steel, and increased surface roughness is observed with increasing stress intensity factor range while the crack propagates. And thank you for your attention.